Hello all, welcome to this session on Puppet. Let's wait a 5 more minutes for others to join in. Hi all, welcome all of you for the Puppet session. I am Anju M. Dominic, Principal Consultant of Quadralogics. I will be the trainer for your session. So if you have any questions, we will take it at the end. So in this session, we will be discussing on what is infrastructure as a code, why we need them, what is Puppet and why we need Puppet or why we choose Puppet over the other tools, and then we will also do simple hands-on examples with Puppet code. So let's start our discussion with infrastructure as a code. So before we go into it, let's understand what is infrastructure of your application. Infrastructure of an application could be anything that helps us to run the application smoothly. Let's take an example. To run an application, you may require configuration files. Implementing and managing the configuration files is a part of an infrastructure. Let's take something bigger. Servers. You're going to deploy your application in various servers. Provisioning and managing the servers is a part of the infrastructure. Infrastructure is hence a big ocean where you'll have so many things included in it. It could be even smaller things like a configuration file or a particular version of the install, or it could be something bigger like to manage the servers, routers, networks, etc. Then what is infrastructure as a code? Infrastructure as a code is an upcoming DevOps practice where the entire infrastructure is abstracted into a high-level programming language. Or in simple words, I would say that the entire provisioning and managing of the infrastructure happens through code. But why we need infrastructure as a code? Why do you want to manage the entire applications or entire application infrastructure using code? We are already fed up with developing application code, but now you need to develop infrastructure code as well. But why we need that? I'll tell you with an example. In my early experience when I joined the industry, I was working for a mobile network operator and it was based in UK. They had around 5 million customer base. So we were handling or we were part of the charging and billing group of the mobile network operator. So there they used to have two teams, development team and operations team. So usually how it was like when an application is complete or a functionality is complete, the developer will release the code to the operations team, and the operations team will take it forward and deploy it into the production environment. Developer team is completely unaware of what is the production environment. Only things they know is their developer environment and their code. Similar is the case with the operations team. They are completely unaware of what is there in the code. So operations teams usually used shell scripts to deploy the infrastructure for the application or to configure the application. But in course of time, we started getting lot of defects, and mainly these were production issues when the application went live on the production servers. After analysis, we could always find that almost 95% of the production issues were something related to the infrastructure configurations. And what we ended up doing was to modify the shell scripts that actually helped in the infrastructure deployment or configurations. Or in other words, I would say, I would end up modifying the infrastructure scripts. But you know how the production issues are. We have to fix this immediately without wasting much amount of time. So since these were captured only in the production environment and these issues needed to be analyzed and debugged in the utmost seriousness and in less time. But what we are having is shell scripts. Shell scripts is another burden as such. We don't have any debugging tools for shell scripts. We have to go line after the line manually and check out the defects. And in most of the cases, if the shell scripts are too complex or your deployment procedure is too complex, our shell scripts usually be too much complex in nature. So it is very difficult to analyze and debug the shell scripts. As a result, we started going off schedule. That means we started losing our deadlines. We were not able to finish our work in time. Production issues were piling up. We never focused on testing these shell scripts, the infrastructure shell scripts, because most of the cases it was completely different from the development team and it was handled by the operations team, and whenever the production issues comes, then only we pick up the shell scripts for the modifications or fixing. And we did not have enough time to do that, as a result of which no thorough testing was done on the infrastructure scripts. As a result, we started getting more and more production issues. We spent almost all weekends in office, and that too on the working days also. I used to leave the office very late. So that was making the life of the developer very, very difficult. That is when we thought of the approach infrastructure as code. So abstract all the infrastructure in the form of code. What is the advantage of that? First and the foremost advantage is that you will get a consistent, reliable environment. So since it is written in the code, it is kept safe. Whenever you run the code in any of the environment, you get the desired results, consistent results. And since the infrastructure is now codable or it is coded, we can apply all the features that we can apply for the application code. That is tracking, versioning, storing it in the source code repositories. These all features could be done with the infrastructure as well now. And there is one another feature that was lacking in the shell scripts. That feature was idempotence. Let's take an example. Now in the shell script that we are going to write, I need to delete a file. Say file1.txt. I want to delete a file. I will write the shell script as, I will use the command rm and give the file name, that is rm file1.txt. So that is the shell script, simple shell script that I have written to delete file1.txt. We ran the script. It was working fine. It deleted the file1.txt. But unfortunately, I ran it second time. What happens? What is the message that you will get? After running the shell script second time, you will get the error or the message stating that file1.txt is not found. That is because during the first run, when you first ran the script, it deleted the file1.txt. So in the second run, it is not able to find file1.txt. But that is not what we expected. We don't want unwanted messages or error messages. So I need to make this shell script idempotence. That is, how much ever time I repeat running of the script, I will get the same output. So how to make this small script idempotence? You can modify the code in such a way that if the file exists, you have to delete the file, otherwise don't do anything. So that is the way you can modify the shell script to include idempotence. This is a small example, but in real life it would be something big. Our shell scripts would be very complex in nature. So to incorporate idempotence in the shell scripts is very difficult. So that is where infrastructure as a code and the tools that help us to achieve infrastructure as a code comes into picture. Puppet is a tool that helps us to achieve infrastructure as a code. And the main feature that we have in the Puppet code is idempotence. There are many tools available in the market that help us to achieve infrastructure as code. You can go for Chef, Ansible, SaltStack, etc. etc. But why we need Puppet? First thing is that it has been around from 2005, so it has a very good community support, documentations. You can pretty much find all the, if you want to check for any information, you can go to the Puppet docs and check the same. And Puppet is mainly written in system admin point of view. That is, even if you are not a programmer and also not aware of the programming, we can do the Puppet coding, because that is written in the point of view of a system admin who is not familiar with coding much. Puppet uses a declarative language and also uses, in some cases it uses Ruby DSL as well, which is very easy to understand and work with. So that is the main advantage of having Puppet to achieve infrastructure as code. Now, let's do some hands-on examples with Puppet. So before that, you need to install Puppet. So for that, let me just launch an AWS instance in my AWS Management Console. So let me go to my AWS console. I am in my EC2 AWS Management Console and I am going to launch an instance. So here I am going to take the free tier version. I am going to use the Ubuntu Server 18.04 LTS server and I am going to select it. And here also I'm going to select the T2 micro free tier eligible one, that is general purpose server, and I go to the next configuration. So number of instance I want is 1. So storage is already, we are getting some storage details there, that is fine. I'll take the default. Now I'm going to add the tags and then configure executable. I'm going to add a new rule to this this instance, that is it has to handle all TCP connections from wherever it is coming. So I have chosen that rule also. So now I'm going to launch it. So while launching, you may be asked for a key pair. You can either use an existing key pair or you can create a new key pair to validate the AWS instance. So here I have my existing key pair, that is puppet test.pem file. So I am selecting the same existing key pair. So here launch the instance. So let me go and view the instance. It will take some time to launch the instance. So it is launching the instance. Let's wait for some time. It is still showing in the pending status. The instance state is in the pending state. I already have other 2 instances in my account, so don't worry about that. Just worry about this new instance that I am creating, and I am going to name that instance as Puppet Master. So yes, it is done. It is initialized. Now I am going to name it as Puppet Master. So the instance is safe now. Now let me try to install Puppet in my AWS instance. So for that, let me just connect to the instance. So this is the command to connect the instance. I go to the terminal, and if I go to the terminal, this is where I have my key file, that is puppet test.pem, which has been used to connect to the instance. So there I am going to type in the command and I am going to log into my AWS instance. So this is the first time, so it will be asked a question like yes. Now I am into the AWS instance. Now let me just go to the GitHub, where I have the installation steps for the Puppet Master. Okay, here the first step that I am going to do is I am going to find out the distribution version, that is what kind of distribution is it. It is Bionic distribution. Now in the next step, what I am going to do is I am going to update the apt-get package manager. So here I am going to paste it, and apt-get update is working fine. It will take some time. Okay, now it's done. Let me just clear this one. Now what is the next step that is required to run the install the Puppet? So I am going to get the Puppet package from the Puppet Labs. So I am using wget. Go to the terminal and get the wget, and yes, now it is finished. So we have the Puppet release bionic.deb package ready. Now just unzip the file. So I am going to unzip this file. It will take some time. Yeah, it's also done. Now I'm going to install Puppet Master. So in the package you have the Puppet Master. So I'm going to install the Puppet Master. 99%. Do you want to continue? Yes, I want to continue. It will take some time. Let me just wait. So here also yes. So what we are right now doing is installing the Puppet Master in the AWS instance that we have just created. So we have done that. Now let me check the status of the Puppet Master. Paste with the apt policy. You will be able to see that Puppet Master is installed. All the details you will be able to see. Now let me just clear this one, and then let's see what is the next step. Now the next step is to start the Puppet Master service. So here the status of the Puppet Master is active and up and running. So all fine now, everything is set up. So Puppet Master is installed in our system. So basically the Puppet works on two modes, master slave architecture and also in the standalone mode. In this session we will be showing the standalone mode with the Puppet Master alone. So we will be running the application or the infrastructure code created using Puppet in the master itself. We are not having node and the connection to the node in this session. It will be handled in the upcoming sessions for the Puppet advanced lessons. So here what I am trying to do is the standalone mode where you have the Puppet Master and all the application would be run on the Puppet Master itself. So our master is ready. Now what I want to do is, let me do some hands-on example with the Puppet code. So this is a sample example. We will revisit the code fundamentals later. So in the first example, let's assume that we are going to create a file hello.txt in the temp folder with the content hello world. So that is, if you go to the cd temp folder and if you give ls, there is no file there specified as hello.txt. Now the requirement is to create a file hello.txt in the path temp using the Puppet code. So for that, first what we do is we create the file, or we create a file where you have the step-by-step instructions to run the Puppet code, and that is also known as manifest. So we will have the manifest written there and it will have the .pp extension. So the first file I am going to create is vim demo file .txt. .pp. Manifest will have .pp extension. So vim is not present, so I will just install vim first, so that it is useful for me to edit the files. You can use any text editor of your choice, Vim or VI or anything like that, Nano or anything like that. I am more comfortable in Vim, so that is why I am installing Vim. That is completely different from what is Puppet is all about. So it's installing Vim, and with Vim we will create a file called demo file.pp that will have the code for the creation of a hello.txt file in the temp folder with content hello world. So we will revisit the syntax later and the keywords later. So just for an example's sake, let's understand that this will create a file in the particular path, say temp hello.txt semicolon. I'm going to ensure that this file needs to be present present, and the mode of this file or the permissions that are there on this file is something like 0644. You can go and check, very well go and check the permission, like you can have 777, that is read, write and executable permissions. That is a combination of read, write and executable permissions, and you get the number like this 0644. And now the comment is what? Sorry, not comment, content. Content is hello world. Hello world. Now I will enter this one and I will run this one. Now let me just clear this. So we have the manifest ready, that is the file that have the application, the Puppet code, and so that is ready. Now, sorry, we have created this in the demo file.pp file. Okay, let's me just run there itself. So here I'm going to check if the syntax for this file is correct or not. So for that you use the command puppet parser validate demo file.ppp. So there is no errors as such. Now let me just knowingly include some errors in the file. So if I go to the demo file.pp and just say I deleted this closing brace, so we don't have a closing brace there now. So here, now let me just run the validate command. Yes, you are getting that syntax error at the end of the input file, that is demo file.pp. So that is how you detect the syntax errors in the Puppet code using puppet parser validate command. So now we have some error, so we know what is that error, so it is easy for us to fix. So we go to the vim demo file.pp and include the closing brace and save it and run the parser command again. So hopefully we are not getting any errors now. So what we have done is we have started the coding, we checked the syntax of the Puppet code. Now we need to test this application first. So since it is an infrastructure code, before you do any changes, that is what we are doing is infrastructure testing. So when you have some unwanted errors in the infrastructure code, it can even affect the working computing environment itself. So that is the importance of testing in infrastructure code. For that note, I would give you an example that there is a live example of Knights Capital. Knights Capital was a US brokerage firm that was based in New York Stock Exchange. So there what happened was they had some 8 servers to manage all the transactions, all the stock transactions, etc. And they needed to add a new feature. So they had the new code, they started the deployment of the new code on their servers. They had 8 servers, so in all the 7 servers the deployment was successful, but in the 8th server it did not work correctly. So Knights Capital did not have a method to check that out. So as a result of which they started getting erroneous messages and they lost around $460 million in less than half an hour. So that is the importance of testing in infrastructure. You should give utmost importance to testing while writing infrastructure code. So how to test the infrastructure code? You can do that in Puppet by running a dummy code. That is, actually it won't run the code, it won't run the infrastructure code, but it will give us what is the expected one, what is the current status of the machine, etc. So for that you can use the command sudo puppet apply --noop. you have to give the name of the file also, that is demo file.pp. So see, the current value what we are having is absent, that is we don't have that file now in the temp path, but it should ideally be present. So that is the testing outcome of this demo file.pp. Now let's run the infrastructure code really. So we will avoid this noob flag actually, and then just type the command sudo puppet apply demo file.pp. So now this will actually create the file in the temp path. So let me just ls. So we have the hello.txt file now, and I will do a clear and show you once again. So you have a hello.txt file now. Now let me just cat it and give hello.txt. It will show that you have the output hello world. So what we have actually done is we have performed an infrastructure, we have applied an infrastructure code. We have created our first infrastructure code with Puppet with hello world example. So now let's go to the PPT. So let's revisit what we have done in the file. So let me just go back to the terminal once again, and let me just cat the demo file.pp. So here the first thing that you need to know is resources. What are these resources? Resources are nothing but like file is a resource in the Puppet code. Resources are building blocks of Puppet code. This is the single element of a system. It could be anything like a file, a package, a service, or anything like that. So if you give the name of the resource, so if you give the type of the resource, that is file is a type of a resource, and if you give the name of the resource in the double quotes here, and then you have to specify the attributes of the file resource. First attribute that we used was ensure. Ensure means it should ensure that it is present. If it is a directory, this particular ensure attribute will specify that the particular file or the particular directory is present. And if it is mode attribute, it specifies the permissions for the hello.txt file, that is the permission 0644. And the another attribute is content, and that is for hello world. There are many attributes available for file. You can go that and check out in Puppet's documents. You will be able to find the attributes for the file resource. I think there are around 49 resources in Puppet code, and each resource will have a plenty of attributes attached to it. And a collection of resources or a single resource, it would be a single resource or a multiple resource, or the collection of resources is what is known as manifest. Or the manifest is the file where you put your infrastructure code, and it will have either a single resource or multiple resource. And a collection of manifest is what is called modules. And there is something else also that is called classes. Classes are nothing but a group of, or you say a bundle of code that is reusable. So you can bundle the code in the manifest using classes, and this code could be reused again and again. So that is the main jargons or main terms you need to understand while working with Puppet. So resources is the building block, manifest resource specifications and declarations and what it needs to do, everything will be specified in the manifest. And the manifest, collection of manifest, is what it comprises of modules, and in the manifest itself you can have classes, that is a reusable portion of the code. So these are basic things that you need to understand while working with Puppet code. Now let me just create a Nginx server or run an Nginx server using the Puppet code. So before that, let's just understand the status of Nginx service. Systemctl status Nginx. Nginx service is not want. Nginx server is a reverse proxy server that is used for all common app servers around. So here we don't have the, sorry, this is not the Nginx, it is Nginx. So you don't have the Nginx service found in this particular installation, in particular instance. Now let me just create another file, demo nginx.pp. So here I'm going to install a package Nginx, that is the another resource. If you want to know more details about this package resource, you can go to the documents puppet.com and see the details about the package resource as well. So here I'm going to install the Nginx package, and here I'm going to ensure that it is installed. Package is installed. And now in the second step, I'm going to use the service resource and service Nginx. I'm going to ensure that it is running. So we found that it is not running. Now we have to make it run. Running. So done. So let me just save this one. And now what is the next step that you need to do? You need to validate the syntax. So how to do that? You can use the command sudo puppet parser validate demo nginx.pp. So there is no error as such, so we are all good now. Now let's test it, run the demo dummy test. So for that you use the command sudo puppet, so not puppet, apply demo nginx.pp noob flag. So it will show us that there is no Nginx package, it is removed, or Nginx package is not present in our system, and the service is also stopped. But ideally it should be present and it should be running also. So let's run this actually. It will take some time. It is installed. So, and if you see, if you I'll just clear this one and let me just run the ctl status nginx. Now the Nginx service is up and running. So this is the simple example what we have done with Puppet code. So remember that we have done this in the standalone mode. We had the master alone and all the configurations, all the infrastructure code were run on the master alone, and we used Puppet apply command to run the infrastructure code in the standalone mode. But if when it comes to the master slave architecture, it is something more complex that will be handled in detail in the advanced session of puppet. But just to give you an overview about the master-slave architecture, in the case of a master-slave architecture, let me show you how it is working. So here let it get launched, that GIMP, so that I can draw and show you what is the master-slave architecture. In the case of a master-slave architecture, you will have a puppet master and multiple or single puppet slave. So the puppet make use of pull configuration. In the case of pull configuration, that means that the entire action is triggered by the slave. So if I go here and create so here, so let it be here. So here I'm going to, this is the master. So this is the master that we are having. So here, for the simplicity's sake, I am going to take only one slave. So this is the slave that we have. So when you start the slave, or there is a code that we need to run on all the slaves of the puppet, that is known as agent, puppet agent. So when you start the puppet agent, it gives the status of the agent or the status of the state of the slave to the master. That is known as facts. Facts are nothing but the state of the slave machine which is sent to master. Master will check the state of the slave machine with the manifest that it has in the puppet master, and after verifying with the manifest, if there are any discrepancies, they will send the catalog to slaves. This catalog will have all the instructions that the slave need to perform to make the state of the slave in accordance with what is expressed in the manifest in the puppet master. So that is, if you go and see the terminal, you can find that when you run the nginx package sudo puppet apply, you can see something like catalog here. So this catalog is a set of instructions that the slave needs to perform so that the state of the slave becomes in accordance with the manifest in the puppet master. And after the slave has done all the actions according to the catalog, it will send the report back to the master. So this is the actual data flow that happens when it comes to the master-slave architecture. So in this session we covered mostly about the standalone architecture, but just remember that we have something called master-slave architecture. And in the master-slave architecture, this is the way it communicates. First, the slave will send the state of the machine to the master. Master will check with the manifest and give the catalog to the slave. Slave will perform the catalog actions and then give back the report to the master. So this will be dealt with in detail in the next advanced session of the puppet. Let me see if we have any questions with puppet. Let me go to the chat window. So as of now, any questions? I have been asked about the Kubernetes training also. Yes, we are planning Kubernetes trainings also from Quadralogics. Most probably in the next week we will be having Kubernetes training also. So any other questions related to Puppet? What is infrastructure as a code, and then how Puppet comes into picture, and how Puppet is better than the other infrastructure as code tools. And then we did a simple hands-on examples with Puppet code working in the standalone mode. So tune in for the next advanced session for the Puppet in the coming week. Hope to see you all there. And if you have any queries or any feedbacks about this session, and also with any Quadralogics sessions that you have attended, please feel free to mail us on info@quadralogics.com, and we would very well note your feedbacks. So thank you all. Thank you for all for joining me here. Thank you very much.